Okay, now we're going to talk about combinations. Now, combinations is when you're selecting things, right? But the order doesn't matter. I think this first example makes a lot of sense, right? It says, how many ways are there to choose 5 cards from a standard deck of 52 playing cards? So we're going to use our permutation approach to first of all figure out how many different ways there are to choose 5 cards if the order did matter. All right, so that's how we're going to start this, right? And so you know that for 1 card, right, there's 52 ways for the first pick, right? The second pick, you've already gotten rid of one of the cards, so now you're down to 51 ways. And then if you follow that same logic using what we did in the last video, right, it gets down to 50, and then you got 2 more cards. You've now taken 3 cards, so there's 49 left. You've now taken 4 cards, there's 48 left. And these are all the different ways that you can select the cards. But this way makes the difference for order. And so I'm going to explain this to you now. All right, so let's say that you choose an ace, a 3, an 8, a 10, and a queen. All right, let's say you pick those cards, right? Now, it never said they have to be in a specific order, right? It just said 5 cards, right? So your first card could be an ace, and then you pick it in this order. But you could also, instead of picking the third one, you could pick the 8 instead of the 3 the second time, and then you could go through your entire order, right, and say, oh, well, if you pick the ace first, then instead of picking the 8, you could pick the 10, and then in the right, and so hopefully what you're seeing is you're saying, oh, hey, wait, this is the fundamental counting principle here. How many different ways can these 5 cards be ordered so you can pick them? And so what we have to do is we're actually going to take that number, right? And we're going to break it down like in the factorial way. So we're going to say it's 5 factorial, right? Because there's 5 different ways, right? So you would say 5 times 4 times 3 times 2 times 1, different ways, right? And then this will give you how many ways you can get it. So when you have a combination and a permutation, the combination's always going to give you fewer options because the order doesn't matter. So it doesn't matter if it's A, B, or if it's B, A. They're kind of counted the same way, right? And so that's how this works. All right, so now that we've kind of talked about that, and I paused the video so we didn't have to hear the principal announcements, let's see how we can clean this up. Now, 2 ways to do this, right? One is to just kind of multiply this, get a big number, multiply this, get a big number, and divide them, right? But another way to do it that might make more sense to you guys is try to see if you can cancel out as many of these as possible, right? You know, using cancellation, right? So let's say I go, oh, well, I know that 2 will go into 52 26 times. All right, cool. 3 will go into 51 or 48. I know the 48 one better, so 3 will go into 48 16 times, right? And then, oh, I know 4 goes into 16 4 times, right? So we canceled that out. And then 5, well, the only thing up here 5 goes into is 50, right? So 5 goes into 50 10 times. And so now you've made this a much easier problem. You don't have to worry about 1 because it's just silly, right? And so now this is 26 times 51 times 10 times 49 times 4. And then you can just put that whole thing in a calculator. And let's do that. All right, so we go 26 times 51 times 10 times 49 times 4 gives you a total of 2,598,960 ways. All right, so 2.5 million ways to choose 5 cards from a standard deck of 52 playing cards. So when you're playing, you know, poker and playing Texas Hold'em or something, that's how many different hands you can get, right? And so the big thing with this is to remember that, hey, you're getting rid of, you're counting each like order as one thing. So you got to figure out how many different ways it can be ordered and then divide by that. And then that helps you. All right, so here we go. We have a restaurant offers a total of 8 side dishes. A customer can choose 3 sides with their entree. How many ways can a customer choose their sides? All right, so the way it goes, right, is you can you've got your 8, right? So your first dish, right, you have 8 choices. All right, so dish 1, you have 8 choices. For dish 2, you now have 7 choices because you picked one. Okay, and then for dish 3, right, you are down to having 6 choices. All right, so these are the number of ways, but that is if order is important. Now the order is not important. If you pick French fries here, it doesn't matter, you know, if you have green beans and corn, or corn and green beans, or anything like that. So we have to figure that out. So how many different ways, right? How many ways can you order the 3 dishes, right? Well, that would be 3 times 2 times 1, right? That's fundamental counting principle. So you go 3 times 2 times 1. And then what's great about this is 3 times 2 is 6, right? This makes 6. And you got 6 up here, so you can cancel this out. So you get 8 times 7 over 1, which is 56. So 56 different ways, right? 56 different ways. So hopefully this kind of makes sense to you. Like I said, with the combination, when you have a true combination problem, you are going to be dividing by the number of ways of what you choose, right? So you'll figure out how many things are you choosing, and that's the number of ways that you're dividing it by. Okay, so in here you're choosing 5 things, so you divide by 5 factorial, or your fundamental counting principle of 5, right? Here, same way, right? Fundamental count, you know, of 3 times 2, 3 factorial, and that's where you get this. All right, so we'll see you in the last video. Hope this is starting to make sense.